Hello and welcome back, dear friends. This is Gulshan Singh presenting today Standard 10th Physics Light Part 3rd. So join us, guys. I provide you complete English grammar and composition course just in 45 days. I also provide you Triple C complete course, the Hindu analysis, Standard 6 to 12 complete courses of all subjects, and many more on your demand which you ask or which you comment us. Guys, subscribe to our channel. You can also join our Telegram channel or WhatsApp us for PDF of this link. Please subscribe us, and without wasting any time comes to our topics: sign convention, mirror formula, and magnification. Guys, comes to our point. As we see on our screen, sign convention for a spherical mirror. While preparing the concept of sign convention in a easy method, we must remember few things, like we just have to focus on the Cartesian system of mathematics for this sign convention. The sign convention for both the mirror are same. Guys, as you see in our screen, objects. Objects is always placed to the left of the mirror, to the left of the mirror. Guys, this implies that the light from the object falls on the mirror from the left hand side. All distances of the principal axis are measured from the pole of the mirror. All distances are measured from the pole of the mirror. Guys, we can understand this. Guys, this is the pole. We can understand it as 0, 0. Here, y-axis represents height and x-axis represents position. Here, objects always be kept in left hand side and their image is formed in right hand side. The real image is formed always between the, if we can understand it. Guys, all the distance is measured from the right to the right of the origin along the x-axis, sorry friends, right of the axis along the x-axis. Guys, we can see on our screen all are taken as positive, those measured from the left of the origin, and taken as a negative, which is on left hand side, Friends, distances measured perpendicular to and above the principal axis, as we can see above the principal axis. Okay friends, also we can say that along the y axis, and taken as positive because of their upward nature, here we can see. Guys, since the object is placed on the left side of the mirror, the direction of the incident ray is from left to right. Therefore, the distance measured from the pole towards left are taken as negative, while those towards right from the pole are taken as positive. Guys, comes to the next one, linear magnification. Guys, magnification is the comparison of the parameters of image so that of object. It is the ratio of height of the image to the height of the object denoted by m. Here we can see m is equal to h2 by h1 or I by o. I by o. Here mistake in slides, so we can understand it. Here height of object h1 is always positive and height of virtual image h2 is positive, whereas height of real h2 is negative. Guys, come to the next one. The linear magnification in terms of position, it is equal to the ratio of the image distance to the object distance with a minus sign. As we can see, magnification is equal to negative of position of image upon position of object. As we can see, m is equal to minus b by u, where minus b represents position of image and u represents position of object. Comparing the values of magnification, minus b is equal to h2 by h1, or also we can see minus b by u is equal to I by o, minus b by u is equal to I by o, minus b by u is equal to I by o. Okay guys, so come to the next one. Here we can see m is greater than 1. M is greater than 1 means magnification is greater than 1. In this case, height of image is greater than height of object. Height of image is always greater than height of object. As we can see, this is a concave mirror, and in this case, the object BA forms their image on right hand side with A dash and B dash, which is larger inside. So we can say that height of image is larger inside. Okay, guys, comes to the next one and see some new facts. We should always know that in concave mirror, m can be less than 1, equal to 1, or greater than 1. For concave mirrors, m is always less than 1. For concave mirror, m is always less than 1. Right? Guys, third point is for plane mirror, m is always equal to 1. For plane mirror, m is always equal to 1. Guys, we should also note that for for virtual image, m is positive. For real image, m is negative. M is greater than 1 means height of image is greater than height of object, because of I is greater than object. O. Okay friends, in this case, image formed is in enlarged form. Okay friends, if m is equal to 1, then the height of image and height of object be the same. If m is less than 1, in this case height of image is less than height of object, so we can say that image form is smaller in size. Guys, comes to the next one, and this is mirror formula. This is our mirror formula. Guys, a mirror formula which gives the relationship between image distance, object distance, and focal length of a spherical mirror is known as mirror formula. I can also say that 1 by image distance plus 1 by object distance is equal to 1 by focal length. So I write it as 1 by v plus 1 by u is equal to 1 by f. Guys, you can understand it. Okay, we should always remember it and never forget this. This is our first and very important formula in physics. In this formula and concept, we can solve many problems. Okay, friends. So friends, comes to the next one. Friends, please like, share, subscribe, and support to GSL. Don't forget to subscribe and like and share, my friends. Support us. Friends, now come to the next topic, refraction, causes of refraction and types of medium. So friends, let's comes to our point, refraction. Generally light travels in a straight line, but we have seen that whenever a light passes through a transparent medium, it changes its path while traveling from one medium to another. As we can see on our screen, when incident ray of light, the light passes through transparent medium, it changes their path while traveling from one medium to another. As we can see, it moves to some angle. It does not passes on a straight line. Okay, friends. So we can say that the change in direction of light when passes from one medium to another, it is basically the bending of light when it passes from different medium. So we can say that this is a refraction. This caused by refraction. In this case, we can see here air is rare medium and the glass is in denser medium. In this case, refract incident ray of light comes and reflected back. It is refracted. In this case, angle of R is greater. Angle of R is greater. We can see this in our next slide in large in larger case. In, as we can say, a ray of light when passes from rarer medium to denser medium, then they deviate from their path with some angle. As we can see on the screen, this is the best one to understand these. So friends, we can understand angle of incident. The angle between incident ray and the normal at the point of incidence is called angle of incidence. Here angle of incident formed. Okay friends, angle of refraction. The angle between refracted ray and normal at the point of incidence is called angle of refraction. Guys, whenever there is change in intensity of medium, the bending of light rays occur. The bending of light rays occurs at the interface of two media. Okay, friends. As we can see on our screen, this is the angle of incident and this is the angle of refraction. This is the incident and this is only refracted. Okay, and the dotted line denotes normal. Guys, come to the next one. When a ray of incident ray passes from denser medium to rarer medium, as we can see on our screen, then the angle of reflection is greater than angle of incident, and the angle of reflection is greater than angle of incident. In how can we understand it? When incident ray, okay, comes from denser medium to rarer medium, means denser medium to rarer medium, then the angle of reflection is greater. Okay friends, hence angle of reflection is greater in and so angle of reflection is greater in this case when ray of light from denser medium to rarer medium. Okay, here we can also listen with R for air, means rarer, and R for refracted ray. Incident ray, when passes from rarer medium to denser medium, then the angle of incident is less than angle of refraction. Okay, friends. We can understand it. Okay. The angle of incident does not equal to angle of refraction. Angle of incident is always less than angle of refraction or greater than angle of refraction. Depends on case from which they passes. Causes of refraction. And this is the best one to understand it. Light does not travel at the same speed in all the media. It travels with different speed in different medium. Okay friends, in different medium due to the difference in the densities of the medium. Okay friends, the bending of light rays occurs at the interface of the media, and this bending occurs due to difference in speed of light. Difference in speed of light. Okay friends, the main cause of reflection of light is the presence of, this point is to be noted, is the presence of particles in that particular medium. If the number of particles are more, then there will be more collision in the medium and hence the speed of light decreases. Whereas in case of laser particles, the speed of light increases. Okay friends, we can understand it. So comes to the next one now. The part of ray. The part of ray that enters the medium first undergone the change in speed, whereas the remaining part is in the previous medium only and there is no change in its speed yet. This results in bending of light and so the direction of light also change. Guys, now comes to the next one. Types of medium on the basis of density of particle. So friends, comes to our first topic, optically rarer medium. It is the medium in which the density of particles is less than the other comparing medium. Okay friends, we can understand it in larger view. Okay, again listen. It is the medium in which the density of particle is less than the other comparing medium. It is also a medium in which the speed of light is more, known as optically rarer medium. Okay friends, as example we can see air is rarer in comparison to water and glass. Air is rarer in comparison of water and glass. Okay. Now comes to optically denser medium. It is the medium in which the density of particles is more than other. The density of particles is more than the other comparing medium. It is also the medium in which the speed of light is less, is known as optically rarer medium. Hence, as example, we can see glass is denser in comparison to water and air. So, guys, noted the speed of light in different medium makes this concept easy to understand. The speed of light is 3 into 10 is to 8 meter per second. The speed of light in water is 2.25 into 10 is to 8 meter per second. It gets decreases. And also the speed of light in glass, it decreases much. It is 2 into 10 is to 8 meter per second. All this phenomenon of refraction occurs because the ray of light incident at some angle with respect to media interface but not perpendicularly. Okay friend, when a light ray travels from one medium to another, the bending of light ray occurs by following certain rules. These rules are as follows. Please remember these concepts. These concepts should be remembered. This is an important concept regarding the speed of light alpha. equal to 1 by number of particles in medium, 1 by number of particles in any material medium. So guys, light traveling from rarer medium to denser medium. In this case, the bending of light towards normal. Okay friends, when light is traveling from rarer medium to denser medium, rarer medium to denser medium, in this case, the angle of refraction is less than angle of incidence. The angle of refraction is less than. The angle of refraction is less than angle of incidence. Okay friends. So friends, the speed of light is also be decreases, and it comes to the next one. Light traveling from denser medium to rarer medium. Medium to rarer medium. In this case, angle of refraction is greater than angle of incidence. Angle of refraction is greater than angle of incidence. In this case, the refracted ray is away from the normal, and their speed also be increases. So friends, we can understand it. The angle of incident greater than angle of refraction. Friends, comes to the next one. Light traveling. When light traveling perpendicularly, no bending of light rays occurs here. In this case, the speed increases or decreases according to density of medium. The angle of incident is equal to angle of refraction is equal to 0 degree. Okay, friends. So, friends, now comes the next one. Friends, our class get to be in comes in ending point. Thank you for your watching and support, friends. I comes with next video topics on refraction through a glass slab. Refraction through a glass slab and the laws of refraction. Friends. So, bye friends. Subscribe and support us. So, bye bye friends.